There is another element of the lens that is important when we discuss focus. It's called the aperture. It may be easiest to describe in terms of your eyeball. Just like a camera, your eye has a lens and a sensor called a retina. If you have a Christmas tree light that is closer to or farther away than where your eye is focused, by the time the light gets to your retina, it is bigger than it should be and is out of focus. What happens when you squint? Well, your eyelid blocks some of the light that comes from the edge and only allows the light that comes straight through the center of the lens to make it to the retina. Instead of an oversized blurry spot, the resulting spot on your retina is considerably smaller. And if you have objects next to each other, the effect of the overlap is considerably less as well. In a camera lens, this squinting is performed by the aperture, which is inside the lens. When you force the camera to close down the aperture, you are said to be stopping down the aperture or stopping down the lens. When you stop down the lens, you block edge light. The larger the aperture number, the more squinting the lens is doing and the more light is blocked. At the same time, you are broadening the range of distances that appear to be in focus, which is the same thing as saying that you're increasing the depth of field. Back to the lens for a second. There is a side effect to stopping down the aperture. It means that less light hits the sensor, and the camera has to leave the shutter open longer to let in enough light to make a visible image. When the aperture is wide open, the lens with an f-stop rating of 2.8, let's say, will let more light in than a lens with an f-stop rating of 5.6. More light means a faster shutter speed. Thus, an f2.8 lens is said to be a faster lens than an f5.6. A faster lens is capable of a shallower depth of field and can take a picture with a faster shutter speed, making it more useful when you're in low light situations. And they're more expensive too.